Today we are going to study section 2 in chapter 3, a very important thing, determining pH and titration process. Well, we can see that titration process a new thing. Still we haven't seen anything like this, and even we've not heard anything by the term of titration. What is titration process? It contains many different things. Inshallah, I'm going to explain every single point and give you a very deep detail. Titration is a process and it extremely depends on the pH value. So last time when we talked about pH, we've mentioned some different forms of equations to get the value of pH, but actually in a practical way we have two different ways to get the value of pH in any medium. So pH value determination of pH value practically. Okay, there are two ways to guess the value of pH practically, okay. The first is instrumentation way, instrument. Well, we have pH meter, and we have indicator. Well, there are two different ways to get the value of pH practically. One of them instruments, and another one is a portable way called indicator. Indicator, it depends on color change. So it depends on color change. Indicator, it depends on the color change. Okay, so stick this into your brain. Indicator identifies pH in any aqueous medium based on color change. Okay, according to the color we can decide the value of pH, but it's approximate. It's not a precise and accurate way, it's approximate. So how we can calculate pH value approximately? Using indicator. But more precise or accurate way and precise way, we have pH meter. So how we can determine the value of pH accurately, more precisely? We have pH meter. So pH meter measures pH in any solution very precisely, very accurately, based on H3O concentration. Okay, and the difference between two electrodes voltage. Okay, that means it contains two electrodes, and the difference between the voltage of the two electrodes and concentration of H3O, it measures the value of pH, but more accurately and more precisely. And about approximate value of pH, we have indicator, depends on the change of color. Okay, look, approximate value for the pH of a solution can be obtained, can be determined using acid-base indicator. So according to the indicators, we can find the approximate value of pH. okay, based on color change, okay? Acid-base indicator. Remember, when we talk about an indicator, immediately you have to remember color, okay? It's a qualitative way. It's not a quantitative, it's a qualitative way. Well, acid-base indicators are compounds whose colors are sensitive to pH. So, if pH change, their color change. That means if we have two different solutions, okay, this one pH equals to 3, it has pH of 5. And another one, for example, it contains solution that has pH 8. So if we put acid-base indicator into each of the following solutions, immediately it pretends a different color, it shows a different color, okay? Why different color? Because of the value of pH changes, so immediately color change. That means any compound that has a sensitive color to pH, it can be used as an indicator in the laboratory, okay? In the laboratory. Any compound that has a sensitive color to change of pH value, so it can be used as an acid-base indicator to get the value of pH, but remember it's precisely, accurately, or approximately. Of course, approximately. This is due to the vision of color. It changes from a person to another person. It means especially between boys and girls, okay? About the boys, we cannot make a differentiate between two closed color, okay? Exactly, but about the girls, okay, maybe they count 20 different colors. But for us, only it's around 10 or 11 colors. So the vision of colors, it changes to a person to another person. That's why it's approximate value. Well, explain how changing pH affects the color of an indicator. Let's see how change the pH affects the color change of the indicator. Well, I will open a white page again and I'll show you how acid-base indicator act differently in acid to the base medium. Okay, first of all, indicators, okay, indicators. Indicators, they are weak electrolyte. So indicators are weak electrolyte. It means that they ionize partially and they dissociate partially if they are ionic compound. Okay. Indicators, we have symbol In and they have a proton. In, it means indicator, and they have a proton they can release, and after that they become a negative ion, they can accept a proton. Indicators are weak electrolyte with the HIN symbol. So they ionize according to this equation, according to this reaction. Reverse direction to producing H plus, plus In negative. Okay, it's indicator. It has red color. Red color. It's blue color. So, when we put indicator into any acid-base aqueous medium, they will ionize first step. They will ionize to producing proton and In negative. It's red color, it's blue color. So, how it acts different, how it acts in acidic medium. Okay, suppose that the medium is acidic. So first medium is acidic. In acidic medium, we have a lot of H plus that produced by the acid. So there are two options of H to react, with H plus or with I negative. Which one will be? Of course, plus with plus, it's no way there will be they won't react together, but H plus, it will react with In negative. So H plus here, I'll show you, H plus plus In negative to producing HIN, which is red color. So when we put indicator into acidic medium, formation of HIN increase. That means dissociation or ionization decrease. So because H plus that produced by the acid, it will react with In. So In acts as a Bronsted-Lowry base. It will accept a proton from the medium to producing HIN, reverse direction. So it means formation of HIN increase and dissociation decrease. So HIN indicator in acidic medium, mostly it will be in HIN form rather than In negative. Okay? Because HIN will increase due to the combination between In negative and H plus produced or provided by the source of the medium, I mean acidic. That's why when we put indicator into acidic medium, the color turns to red, because all the In negative accept a proton in the medium which is acidic. Okay, they become HIN, which pretend red color. So indicator in acidic medium, formation increase, dissociation decrease, mostly will be in HIN form and dissociation decrease. That's all about indicator in the acidic medium. But about in the basic medium, again, we have HIN. H plus In negative. It has red color. What a wonderful red. Red color. It's blue color. So this time we will change the medium to basic medium, alkaline medium. In basic medium, we will get OH that provided by the source, which is by the medium, which is base. Okay. OH, it will react with H plus to producing H2O. So now here will be lack of H plus. And HIN looks around and it will see there is no H plus. And it will dissociate to producing or to revenge the loose amount of H. Okay? Or to offset the loose amount of H that reacted with OH provided by the source, so it will dissociate more. And when every single H produced, immediately it will react with OH. So there will be no H plus, and it will dissociate again. Here there will be a big chance for In to be increased because of it won't go through any reaction with any particle. And H plus, it will react with OH that provided by the base. And In, okay, stay increased continuously, because here will be more dissociation to offset the H plus. That's why the color of indicator in basic medium, it will be blue color, because the dissociation of the indicator increase, formation decrease. HIN indicator in basic medium, it will be mostly in IN form rather than HIN form. Okay, that was all about the principle of pH that affects the color of indicator. Okay, I have talked about all of the following sentences and I showed you how it works. Well, in acidic medium, color of indicator it's red, in basic it's blue, in neutral it's green, of course, it's green. The dissociation of HIN indicator. Let's see. The dissociation of HIN indicator in acidic medium, of course, it decreases. It decreases. The dissociation of HIN indicator in basic medium is, in basic medium, it increases. The HIN indicator in acidic medium presents. In acidic medium, it presents by HIN. But in basic medium, IN negative. It has red. It has blue color. Okay? So it's acidic medium. It's basic medium. Right? HIN. The HIN indicator in basic medium presents IN negative. It's in acidic medium and we don't have the followings. About the universal indicators, we have a lot of different indicators in the laboratory, so you may confuse which one it has a widest range of working that is suitable for any type of mediums. Actually, we don't have that kind of indicator. So the chemists, they thought about to preparing a universal indicator that contains a lot of common indicators, okay, when they mix it together. Look, universal indicator, general indicator are made by mixing several different indicators. Well, we just prepared a mixture of indicators and then we soak a paper called pH paper and then we let dry. And now this paper contaminated by universal indicator. If we put this paper into any medium, it will provide a different color according to the pH of the medium. Then we can decide what is the pH value of that medium. Look, it's a piece of pH paper. Okay, pH paper. When previously they contaminated to the universal indicator, okay? And now if we put this paper into any medium, okay, it will pretend one of the following color, not all of them together. This is standard, okay? This is standard. Okay, we have this standard. Well, suppose that, okay, I'll bring red color. Suppose that we just obtained this color, so which one will be? We don't know. So we can decide approximately it's between 0 to 1. Okay, it's between 0 to 1. Or suppose that we have another color. Okay, what color will be? For example, yellow color. Okay, you will confuse what color matches with your paper's color. Okay, you don't know. So you will select approximate value. It's between 2, 3, 4. Suppose that you just obtained a blue color and you will confuse which one matches to your color. For example, this color. Which one matches to this color? You don't know. So you will select it approximate value. It's between 11 to 12. That's why I said determination of pH value using indicators, it's approximate way. It's not efficient and accurate, precise way. Please don't get zoom it without my recommendation. Don't make me angry. Okay. No, actually, I'm very cool. About pH meter calculates pH value very precisely. I don't know for what I bring this. It's a smart board. We don't need a marker. Well, it's pH meter. It contains a sensor. If we put this sensor into any medium, it will read the pH of that medium in its screen, even by a point, very precisely. Look, pH of tomato, it's 4.1. I don't know it produced by which country, but I'm sure that it's not. I'm sure that our tomato, I mean Kurdish tomato, it presents a pH below 4 because of our tomato is very acidic. Well, pH meter determines the pH value of a solution by measuring the voltage between the two electrodes, and of course the hydronium ion concentration is very important. H3O concentration. Well, the voltage between two electrodes. The voltage changes as the hydronium ion concentration in the solution changes. pH paper provides fairly accurate, that means it's not a precise, it's not a very accurate, fairly accurate way to distinguishing the pH of solutions. But pH meter measures highly accurate way of pH of any solutions. We have many types of salts. Before studying the titration, we have to be familiar with the types of salts. It's very useful, dear students. Never forget types of salt. Salt. Okay. What are the types of salt? Firstly, we knew that salt is an ionic compound. It contains of ionic assembly between the cation and anion. The cation mostly provided by the base and an ion provided by the acid. Okay, so the reaction between acid plus base. We will talk about those salts that are provided by the acid and the base. Well, for example, if the acid is strong, acid, acid, we don't know who is acid, plus base. Well, we don't know base also, but we have to respect them. Well, when they react together, if both are strong, the acid called neutral acid, the salt called neutral salt. Neutral salt, it has pH of 7. pH of 7. For example, NaCl. Cl provided by HCl, Na provided by NaOH. It's neutral salt. We have another type of salt contains from strong base plus weak acid, such as NaCN. It comes from HCN and it's from NaOH. So this is called, because of the base is strong, the acid is weak, so the salt will be basic. Alkaline salt or basic salt, because of its base, so it must show pH above 7. Another type of salt, strong acid plus weak base. This time the acid is strong, so the salt will be acidic salt, such as acidic salt, NH4 by 2SO4. Okay, it came from the reaction between HSO4 and NH3 or NH4OH. No problem. Because of its acid, so pH must be smaller than 7. And the last type of the salt comes from the reaction between weak acid plus weak base. There's no name for this type of salt. We just say salt of weak acid and weak base, and it could be acidic. It could be basic or neutral. pH of the medium depends on Ka and Kb. Wait for chapter 6. In there, you're going to get a very deep knowledge, such as NH4F. It came from HF and it's from NH3. So we can see that both of them are weak. Okay? As I said, both of them are weak. So the salt called salt of weak acid and weak base, it can be acidic, basic, or neutral based on Ka and Kb. Ka is for acid, Kb is for base or base, no problem. Okay? تمام بابی من؟ ئەوە زۆر بە ئاسانی دەتوانی هەزمی کێ ئەو بابەتە هیچی تێدا نییە. باشە بەبەم ئەوەیان تەواو بوو. ئەوە جۆرەکانی sorry, these are many different types of salts with more examples. Okay, which of the following salts has the highest pH value? It's neutral. It's neutral. It has pH of 7. It's acidic. It has pH smaller than 7. So still now it wins the match. NaF, it's basic salt, pH greater than 7. KCl neutral, pH equals to 7. So which one pretends the maximum pH value? Of course, the answer of C, NaF, pH bigger than 7, it's basic salt. Basic salt or alkaline salt, it came from the reaction between NaOH plus HF. So this is called basic salt. And now we just approach the main point, which is titration. What is titration process? Well, actually, I don't like to talk about the definition of the titration because of the definition is another thing and the aim of the experiment is another thing. But for you, you are mandatory to, it's mandatory to be memorized. You are obligated to memorize this definition, and after I finish the explanation of titration, you're gonna get the idea about the titration very easily. So don't be hurry and don't confuse. It's very easy, nothing. It contains nothing really. Titration, the definition, it's obligate, it's mandatory. What is the importance of titration? Titration provides a very sensitive means of determination the chemical equivalence amount of acid base. So it's a benefit of titration to determining the chemically equivalence amount of acids and the base. Well, maybe one day you went to the laboratory and you just opened some doors in the laboratory and you've seen chemicals that are stored in a plastic bottle. They called primary standard. Primary standard. What is primary standard? Primary standard, first of all, it's a solid. It's a solid compound, okay? It's a highly purified solid compound used to check the concentration of the unknown solution in a titration process. Actually, from the primary standard, we will prepare standard solution. So the expression of standard, it means known concentration. Known concentration. Known concentration. What is standard solution? It means its concentration is known very well. So how we can get the standard solution? So what standard solution is? A solution that contains a precise known concentration of solute. Actually, this is apparatus of titration. Well, let's get back to the titration. Well, this is apparatus of a titration manually, and now it's instrumentized this process. Based on the instrument, we can do this very easily. Well, what is titration process? The titration process, first of all, it's a reaction between the acid and the base. It's upper part of a titration, it's a bottom part, okay? So here, we have to fill with a standard solution. Standard solution, it means known cons. Here, unknown concentration. Solution of HNO3, for example, unknown. Unknown concentration. And here, so we have to put acid and base. If it's acid, it must be base. If it's base, it must be acid. No problem. But the point is, here is used for known concentration, and from here we have unknown concentration. Well, we are looking to calculate the concentration of unknown substance, unknown substance, which is acid or base, doesn't matter. Well, for example, in this process, we have HNO3 with unknown concentration, and we have a plan to get the concentration of HNO3. We have to react it with a base with known concentration. Well, here known concentration, here unknown concentration. Still, it's one unknown. Okay. We have to add other substance, but I don't want to talk about this substance. By the end of this process, I'll tell you. Well, we will open here, and it will start to drop down, drop by drop, and you have to mix this with other hand. It's called titration. Before starting here, we have acid, so it contains a lot of amount of H3O because of the medium is acidic. As much as the base is added, the OH concentration will increase continuously. It will increase, okay? Until there will be a very narrow range for them to get equal. Look, still they are not equal, okay? A very small range, okay, is between them. By the end of last drop, they will be equal. But because of we don't know this drop contains how much, how many, the concentration of the base, we don't know it contains how many base molecules. So immediately we will escape this step that they will be equal. H3O, it will be equal to OH. This step will be escaped because we will add drop by drop. Maybe by the part of this drop they will be equal, but we cannot add a part of drop. We will add one drop completely. So if we add one drop completely, immediately everything will change. So then H3O will be smaller than OH. So the medium turns to basic medium. And now the medium changes from the acidic to the basic medium. So immediately we have to close. Now we will read the volume here. So volume, it's known. Volume, come on, okay. Volume, it's known. And previously, we knew, okay, the volume of here. It's known. Okay, but mister, how we can know the medium change it from acid to a base? Remember, I told you we just added another substance. This is called indicator. When the color changes, immediately you have to close the valve. Okay, but what if we don't have indicator? We have pH meter. If pH meter change it rapidly, immediately close the valve. It means it's end point. End point. So end point can be calculated by indicators or pH meter. What will happen if we use indicator? The color change. What about pH meter? There will be a very big rapid change of pH. It will change from, look, this is 7. It will go below to upper 0, or it will go upper to below 0. Immediately close the valve. It means we just approach end point. But what about this point when they will be equal, which is called equivalence point? Equivalence. Come on. Okay. Equivalent point. So about the equivalent point, we cannot, it's impossible to get equivalent point practically. So we will go to endpoint immediately. And after we approach endpoint, we will approximate the position of equivalence point. So how many options do we have to detect the endpoint? Indicators and pH meter. During the indicators, color will change. During the pH meter, there will be a very rapid big change of pH value. So that was the titration process. Equivalence point is the point at which two solutions used in a titration, they are in chemically equivalence amount. It's a benefit of titration. Okay, my dear students, don't forget its benefit, its aim of the titration process. Endpoint is the point in a titration when indicator changes color, or there will be a big rapid change in pH value. What can be observed about the rate of change of the pH solution near the end point of the titration? Rapid and high change in pH value. So it means in case of pH meter, at equivalence point we have the following properties. H3O and OH, they are equivalent, but remember it's approximation. We will just approximate the position of equivalence point because it's undetectable. The point that is detectable is endpoint. Volume of the solutions are present in a titration are chemically in equivalence amount. So indicators can be used to detect the equivalence point and it must change color. pH meter can be used to determine the equivalence point when there will be a rapid change of the pH value. We have some questions about. In acid-base titration, the volume of two solutions, as I told you, you have to memorize, they are chemically equivalent. In the titration of NaOH and HCl, a rapid change of pH value. Rapid change of pH value, it means equivalence point and end point. Equivalence point and end point. Well, we have talked about these notes. They are very simple, and the point that I will let for you to memorize, it's a table of indicators because of it's not a randomized. We have to select the indicator according to the strengths of the acid and the base that use it in the process. For example, if a strong acid and strong base uses, the salt is neutral. So pH equals to 7. We have two indicators. The best one is bromothymol blue. For strong acid and weak base, we have acidic salt. pH smaller than 7. We have two indicators. The best one is methyl orange. Orange, it has a sour taste, just it's for memorizing trick, it's very good. Weak acid and strong base. Weak acid and strong base, it's basic salt. It's a basic salt, pH equals or pH greater than 7. We have two different indicators. The best one is phenolphthalein. With the range of their pH is very important. So please, my dear students, you have to memorize the But maybe you note that there is no titration between weak acid and weak base. Remember? We don't have weak acid and weak base titration because of, as I told you, pH, it's undetectable for that kind of titration. So we don't have any indicator. Look, why aren't there any suitable indicator for a weak acid and weak base titration? Because pH at the equivalence point of weak acid and weak base could not be calculated. That's all. pH value cannot be calculated if both of them are weak. What is the role of indicator in the titration process? As we said, color will change. Okay? On what base an indicator select? According to what base we will select it? As I told you, pH value. So according to the pH, we will select any indicator for any titration process. Look, here we have 3 notes. 1, 2, 3. I have told you and I have explained it every single point in the following notes. By starting of this video, just return back to the starting point of this video, you will get the idea about each of the following notes. The last thing that's remain is transition interval. What is transition interval? Any indicator, before changing color, there will be a sensitive range of pH. Okay? That color starts to change. Okay? From this range. This is called transition interval. Transition interval is the pH range when the indicator change color. Okay? So this range, when the color of any indicator starts to change, called transition interval. Okay, let's answer these questions and we will finish this lecture. Okay? The neutral solution turns pH paper, look, acid, it's red, base, it's blue, neutral, it's green. Okay? What is the equivalence point between pH? What is the equivalence point between HCl and NaOH? Look, both are strong. Strong acid plus strong base. So the salt will be neutral. For neutral salt, pH equals to 7. pH equals to 7. pH of methyl red, you have to memorize, as I told you, 4.4, okay, to 6.2. How do you find the equivalence point and end point? As I told you, we have 2 options, indicators and pH meter. Indicators and pH meter. Indicator color will change. pH meter, there will be a rapid and highly change in pH value. So that was everything about the titration. I know that I explained it very quickly, but hopefully at least I make everything easier than before for you, inshallah. بەم شێوەیە کۆتایی بەوانەی ئەمڕۆمان دێنین تاوانێ داهاتوو بە خواتان دەسپێرم خواتان لەگەڵ